Okay, anyone needs to share the screen? Otherwise, Mr. Mark, you share your screen.
Okay.
Can go for orifice.
Yes, so please provide orifice.
Okay, I've done already.
Okay. Now we need to provide the pump curve data. Okay, so how to do that? So there is database next to file, edit, view, then database. Click on that. Right, then click on booster because we're talking about pump. So one window will open. You can click on centrifugal pump. Okay, then at the bottom you see there is add. No, not that. Down. Don't use the scroll bar. Just see at the bottom there is add, import, load. So click on add.
Oh, okay. Okay. Okay, add.
Add.
All right.
So another window will open. We'll call it as test P5. Test pump 5.
Test P5.
Yes. Then okay. So that's the tag number of our pump. Right?
Okay.
So on the right side, if you see, there is capacity curve data, third last line. Then there is efficiency curve data here.
Yeah. Yeah.
Yes. So click on that capacity curve data. Capacity curve data. Close this window.
Sorry.
Third last line, capacity curve data. Okay, so let us put some numbers. So at the bottom you see there is add. So click 6 times add because I'm going to provide you with 6 data. Flow versus.
I'm waiting for you.
Now you need to click add 6 times. So 5 more times.
What do I add? Under flow.
You click on add.
I've clicked add already.
Yeah, you need to add 5 for 5 more times.
Okay, 5 more. Okay.
Yes, correct. Because I got 6 data points. One more.
Okay.
Yes, sir. Right. So first point is 0 meter cube per hour. Okay, that is already there. Then second line, 90 meter cube per hour, 90. Then the third one is 270, 300, 360. Then last one is 450. And the corresponding head, when the flow rate is 0, shut off head is 35, 35. Right, 34.5. 32.2. 31.4. 30. Then 28. All right. So the plot, what you see on the right side, that doesn't seem to be a smooth curve. So we can change the equation order. The second line on the top, you see there is quintic equation order. Instead of quintic, go for quadratic. If you give more data points, like more than 12 or 15, then whatever equation order you use, it will give the same smooth curve. But since you are given only 6 points, so it is acting a little strange. Now the minimum limit and maximum limit you need to provide. That is a minimum or say preferred operating range, minimum flow and maximum flow. Let us put 30 as minimum limit.
30.
Minimum limit, not maximum. 30. And maximum is 400. Okay, you see the vertical red lines on the plot?
Yeah.
So if your pump is running less than 30 or more than 400, so there will be a warning in the messages. in FluidFlow.
Yeah.
Let others also copy this.
It's running outside BEP.
Sorry.
I said once it's outside its zones, it's outside the BEP.
BEP is different concept, sir. It is preferred operating range they call.
Okay.
Pump vendor will tell that the flow rate should not be less than this or more than this. Then he'll give the guarantee for the pump.
Okay.
All right. So once it is done, other guys, if it is done, please write done.
Well, click OK.
And now let others also copy this.
Okay. So,
All right. Sankar sir, is it done? If you need help, please ask.
Searching for the curve fit.
Yeah, curve fit what? You can change the equation.
Window.
You can go for quadratic.
No, for the window, exact database editor boosters.
I didn't get your question.
I'm just finding a way to open that window.
Okay. So we first go to database, then there is booster.
Yes. On there.
Okay, so you'll see
centrifugal pump.
you can select centrifugal pump, then click on add. Then one window will appear. Right, you will give the name. Okay, have you given the name? Test P5.
test P5. We typed it before. Okay, that's it.
All right. Then if you see this third last line here, it says capacity curve data.
Capacity curve, yeah.
All right. So this data you need to type. Once it is done, please tell me.
Sir, I have closed all the windows, but the data is saved. Ajay sir.
Yes, sir.
Sir, I have closed that windows. Okay.
Okay, there is no difference in the flow. That's what you're saying.
And so far we are not click calculate, but our data is not yet complete. You are only given capacity versus head. Right? All right. So your pump is this test P5. Shankar sir, have you completed this capacity curve data?
Yes, sir. The fifth data only incoming.
Okay. Please finish it first. Then we'll move to efficiency curve data also.
Yes, sir. Completed.
All right, so I'll click OK. Now the next is efficiency curve data, right?
Okay.
So you can
Hmm.
open that also. Here also 6 points you need to add, sir.
Okay.
So 0, then 90, second point 90, 0,
0, second is
yeah, second is 90, 270,
third.
300, 360, and then 450. Efficiency starts with 0, then second point is 45, 73, 70, 57, the last one is 25. All right, so this looks like a pretty smooth curve, so no need to change the equation order.
How about the
Minimum and
limits?
maximum limit, yes, you need to change 30 and 400. I'll let others copy this, then we'll proceed.
So this one no need to change quadratic.
Yeah, the equation order we had changed to get this smooth curve.
Quadratic is still better. Slightly.
Doesn't really matter much as long as it is smooth. But in real project problem, you will not settle for only 6 points. You will take many points, minimum 12. So who would give this data, firm core data?
Vendor.
Yes, it will be given by vendor. All right, Sangar sir, is it done?
Yes, sir. Done, sir.
All right, click OK. Then again OK. Then select both the pumps. All right, so you had used for the pump automatically size on, right? So that now you'll use off. Automatically size, you'll make it off. Okay, you'll see that.
Sorry.
You'll see that
Okay.
pump model has arrived, right? So you can click on that. You have got your own pump now. Test pump 5. Type T.
Type T.
No, just type T.
Type T. Where do I type it? That's the problem.
Here, anyways, just type T. So it will take you closer to your pump.
Okay.
All right, then click OK. You are not provided the table for the orifice. We need to know what is the pressure drop. So let me select show friction loss is here, friction loss. Then click OK, and alignment we want on the left. All right, and the unit I don't want Pascal, I want bar with 2 decimals. So pressure drop unit bar and with 2 decimals.
Sorry. Pressure drop bar, okay. And 2 decimals, okay.
Yes. So this is all set. Please save it and then click calculate. See what happens.
Wow.
So
This is great.
let me increase the view a little bit.
It's great.
So the first exchanger, first loop, delta P across that orifice is 0.43. right? Next one is 0.2 and the third one is 0.16.
116,
It also calculates the orifice size. Like the first one, click on first one, then go to results. So it would tell what would be the orifice size, which is 70.4 mm. Right?
Mm.
The same goes for here. We can put that in the table also, which I think I forgot to do that. But nevertheless, we'll continue with this. Right. So this is one way of solving the problem. And if you have not much fluctuation, too much fluctuation in the flow rate, then adding the restriction orifice is the best option. But Dr. Joseph, if the flow rate is changing, like sometime it is say 100% capacity plant, sometime it is 80%, sometime it is 120%. So that time flow rate would also change accordingly. So that time
Okay.
a restriction orifice will not be of that much help, right? Because it is not really controlling anything. Okay. So in such cases, flow control valve, the automatic flow control valve would be a costly, but it will be a better option, right? So,
Yeah.
okay, let us put that also in that option also we'll study. So let us select all three orifices. But before we proceed, please tell me everybody has got this.
Sir, I have missed one efficiency point number, sir.
You missed one efficiency point.
Change unit of friction loss.
Yes, I'll tell you. Before that, let me go to booster. Then centrifugal pump. Test pump 5. All right, this one.
Yes, sir. Just a second. Efficiency curve data. The points. Yes, sir. Just a minute, sir.
Okay, this example is available in your the folders.
Done, sir. Done. This one is done.
Yes, somebody asked how to change the unit of the pressure drop, right? So you right click on this unit, result unit. Earlier we changed from kg per second to meter cube per hour. So in the same window below, you'll find this pressure or head drop. So you can change to bar, and the decimal place you can change to 2.
From where, sir? The unit came from where, sir?
You need to right click on the flow sheet, then
Okay.
click on result
Okay,
unit.
okay.
We have done this earlier.
Yes, yes.
All right. So we had the problem of water imbalance. So are we able to solve that problem? Each loop is having 99.8, right? So in real world, it is 100 meter cube per hour. Okay. So who did not get this yet?
I'm getting 0.7 bar
0.7 bar. Where?
for the orifice.
First orifice. So that is probably because some input is not matching. Okay, so as long as you are getting some answer, which is okay, but you need to check that we are talking about the same input, right?